In this video, we introduce the concept of free fall. And we explain how to solve free fall problems and give examples. Please subscribe us and watch the video to the end. Free fall. The motion of an object, when the only force exerted on it is the force of gravity. From this definition we understand that we should not consider the force of air resistance, or any kind of friction. And in fact we have to assume, the body falls into a vacuum.
Historically, Aristotle thought that heavier object would reach the earth sooner. For example, we release a ball and a piece of paper together, and see that the ball reaches the ground sooner. But Galileo experimentally showed that this was not true. He dropped two similar metal balls from the Leaning Tower of Pisa, and observed that the two balls hit the ground at the same time. According to the experiment, Aristotle's claim had to be corrected. Now consider the paper and ball test again. If we crumple the paper first, and then release it, both will fall to the ground together. This shows that air resistance causes this. If we release a paper sheet and a metal ball on a planet that has no air, the two will reach the surface of the planet together. This is because there is no air resistance.
The following examples will help you to understand this. A paratrooper jumps out of an airplane. Answer A. Because the paratrooper comes down in the air, there is air resistance, so this movement is not free fall. Because in free fall only one force enters. It means only the force of gravity. B. The footballer shoots the ball. Answer B. Because the ball is thrown in the air, there is resistance. So this is not a free fall. C. Throw a ball at the moon obliquely. Answer C. Because the moon has no atmosphere, there is no air resistance, and the only force on the body is gravity. So this move is free fall. Many people think this is not a free fall. But they are wrong. D. The movement of the earth around the sun. Answer D. Because the only force that enters the earth is the gravitational force of the sun, and the earth moves in a vacuum, then it is free fall. Similar to part C, many people think this is not a free fall, but they are wrong. In fact, the earth is always falling free. E. We release a rock near the ground. Answer to E. If you think this is a free fall, you are wrong. When rock is released on the ground's surface, there is air resistance, so is not free fall.
How should we solve the problems of free fall? Free fall is a special case of motion with constant acceleration. In free fall, the acceleration is constant, and is equal to 9.8 meters per square second, and denoted by g. For ease of calculation, it is usually assumed g equals 10 meter per square second. Therefore, constant acceleration formulas must be used to solve problems. To do this, you need to take a good look at part 18. To solve free fall problems, we use the following method. We select the appropriate coordinate system. Usually we assume the surface of the Earth as the origin of the coordinates, and upward direction is positive. We denote the sign of three quantities: acceleration, velocity, and displacement. To do this, each of these three quantities that are in the same direction as the coordinate axis is positive, and if they are in the opposite direction of the coordinate axis, it is negative. More explanation. Determination of gravitational acceleration sign. The direction of gravitational acceleration is always downwards, so we consider its value negative. Determination of the velocity sign. If the object moves upwards, velocity sign is positive. If the object moves downwards, velocity sign is negative. Determination of the displacement. The displacement vector is plotted from the start point to the end point. If the displacement vector is upwards, the displacement is positive, and if it downwards, the displacement is negative. Then, using the Part 18 method, we find the appropriate formula.
Example. From the top of a rock, we throw an object upwards at a velocity of 10 meters per second. After 4 seconds, the object reaches the ground. Calculate the height of the rock. Answer to A. We consider the surface of the Earth as the origin of coordinates. Assume the upward is positive. Because the object is thrown up at first, the initial velocity is positive. Because we assume the upward is positive, and the gravitational acceleration of the Earth is always downward, it is negative. Note that in free fall questions, there is no talk of gravitational acceleration, but we have to put it ourselves. We know that it is equal to 10 meters per square second. Now we use the Part 18 method. We have the initial velocity, acceleration, time. We want to calculate the displacement, so there is no need for final velocity in this question. The appropriate formula is determined. We put the values in it. The height of the rock is calculated.